talk about practice questions on functions for international GCSE Edexcel. Pay attention very well because it's an important lesson. What are the points that we're going to study today? The practice questions. We're going to do some practice questions from the past papers on domain of the functions and what are the excluded values. We're going to do substitution in the functions, composition of functions, and the inverse of the function. So let's proceed and see how we'll do them. The first question from the past paper says the function f is such that f of x equals 3x minus 5 all over 4. We need to find f of negative 7 and then we need to express the inverse. So we'll do the steps in here and everyone pay attention very well. If you do substitution, if you want to do substitution in the function, the value that's included in here between the two brackets must be replaced. You'll go replace each x in the rule of the function by negative 7. So you can find now f of negative 7 as 3 multiplied by negative 7, then minus 5 all over 4, and then you need to calculate. So it will be negative 21 minus 5 is negative 26 over 4, so it will be negative 13 out of 2, or can be written as negative 6.5. If I need to find the inverse, you need to follow the following steps. The first thing is you're going to replace the function notation by the letter y. So it's going to be y equals 3x minus 5 all over 4. So what's the next step then? You will swap or change the places. Each y will be x and each x will be y. So it's going to be x equals 3y minus 5 all over 4. So the next step is you will try to make y subject again. So it will be 3y minus 5 equals to 4x. Then you will shift the 5 to the other side. So it will be 4x added to 5 equals 3y. Then you divide by 3. So y will be 4x plus 5 all over 3, but this is y inverse because it's the inverse function. So this leads you to have the inverse function, which is f of x equals 4x plus 5 all over 3 all over 3. So in this part, again, what are the steps to find the inverse of a function? What you will do is, first of all, you will change the function notation, which is f of x, by the letter y, and then it will be y equals 3x minus 5 all over 4. Then each y must be replaced by x. So whenever you have any y in the whole function, replace it with the letter x, and each x must be replaced by the letter y, and then try to make y subject again. Then once you made subject y, the y subject again, so you must call it y inverse because this is the inverse of the original function. Let's see here point C and D. In point C it says the function g is such that g of x is equal to root 19 minus x. Find fg of 3. What does it mean fg? This means composition. What's the composition of two functions? It means you are putting a function in another function, so you're going to have a new output or a third function. So if I want to find fg of 3, this is f of x here, and here's g of x. So let's write f of x beside g of x here. So it will be f of x equals 3x minus 5 all over 4. So if I need to find fg of 3, you need to pay attention very well in this case. The first thing is you will do substitution by 3 in g of x first. So you will go in the g of x, replace each x by 3. Then the answer you get, or the result you get from g of x, take it and replace each x by the new result. So let's do it step by step. First of all, I will get g of 3. It will be the square root of 19 minus 3, which gives me 4. So this result that you got from g of 3 is 4. Go replace each x in f of x by 4 because f is the second letter. So the first letter is g. You're going to replace each x by 3 in the first letter. And then the result you got from the g of 3, which is 4, you go replace it in the f. So now I need to find f of 4. It will be 3 by 4, then minus 5 all over 4. So it will be here 12 minus 5, which is 7. So it will be 7 out of 4, or it can be written as a decimal. So again, how do you get the composition or the value, the substitution of a composition of two functions? You will do first, you will replace the one which is the second letter in here, the 3, you replace just 3 here. So it will be 19 minus 3 below the square root. It's going to be 4 because square root of 16 is 4. And then you take the 4 which you got from the g of 3, replace it in the f, which is the one which is out here. So you'll just replace this one. Which values of x cannot be included in any domain of G? Look here. What are the points that are excluded or not included in the domain whenever I have a square root function? G of x equals square root of 19 minus x. You must take this one as a hint. It's very important. So let's change the color. The function, whenever it's a square root function, this is called square root function. So the domain of this must be greater than or equal to 0 in this case. So what's below the bracket must be greater than or equal to 0. As you know that the square root can be only done for the positive numbers. So you cannot calculate the square root of a negative number. So it means whatever is written below the square root must be positive or 0. Again, this point, how do you get the domain of G? What does it mean, the domain? All the possible values for the x. So when you try to draw the graph, you're going to know all the possible values of x, or when can you sketch the graph of this function. But I'm not talking about the graph now. I'm just talking about the algebraic possible values that we can use. For the square root only, all positive values below the square root can be used, but all negative numbers cannot be used. So the 19 minus x must be greater than or equal to 0. Consider this as an equality, just solve it. So what we will do is, it will be negative x is less than or equal to, it's greater than or equal to 19. Greater than or equal to 19. Negative 19, so just multiply by negative 1. As we know, the inequality will be reversed. So x will be less than or equal to 19. This is the domain. So all values which are greater than 19 cannot be accepted. This is called the domain. And the inverse of this, all values which are greater than 19, these are the excluded values. These are the excluded values from the domain. Again, this part, I need first to find the domain for the g of x. What are the possible values that can work here below the square root? What did I do? I took what's written below the square root and I made it greater than or equal to 0. So why what's below the root is greater than or equal to 0? Because all the values below the root must be positive or equal to 0. I just solved the inequality by shifting the 19 to the other side. It becomes negative 19, then I have minus x is greater than or equal to negative 19. As you know, in inequality, the inequality's properties, what do? When we multiply by negative or divide by negative, the sign, the symbol will be reversed. So the negative x becomes x and the minus 19 becomes positive 19. So the possible values of x, or the permitted values of x, must be x less than or equal to 19. If you want to try to make sure that you are correct, you can replace x by 19 or anything or any number lower than 19. So all the values will be positive. But here it's mentioned we need to know what are the values must be excluded. Anything which is greater than 19 is excluded. If you try to put 20, for example, 19 minus 20 is negative 1. There is no square root for negative 1. 19 minus 21, for example, is negative 2. So all the values greater than 19 are excluded. You can just take it as a hint. For example, if the domain is x less than or equal to 19, you will take the inverse symbol. So if it's less than, the excluded will be greater than. If it's greater than, the excluded will be less than. This is the idea of the excluded. So the answer for this part is x greater than or equal to 19 for this part. Let's see one more question and let's make sure they understood. In a normal G are defined as if x goes to 1 plus 1 over x and x is greater than 0, so x here must be greater than 0. G of x with G is defined that x goes to or intends to x plus 1 all over 2. Given that H is the composition of f and g, as we know, when the two letters or the two symbols of the functions are written stuck together, there is no space in between, so it means this is composition. Composition again is putting a function in another function, so we have a new result or a third function like h. We're having function f and then function g. When we made a composition, we got a third function which is h. The question says, given that h equals f composition g, express the inverse function h inverse in the form h inverse x intends to. So we need to find the inverse of h. First of all, I don't have h. I need to find the composition of h. So let's do it. If I have f of x is defined as 1 plus 1 over x, and g is defined as x plus 1 all over 2. We need to find f composition g. So pay attention in the composition. What do I do exactly? It's pretty easy, but I need you to pay attention very well. The steps of the composition. First of all, look at the first letter. The letter f is 1 plus 1 over x. So what you will do is you're gonna write the first letter or the function of the first letter as it is. If this is f, so you're gonna write 1 plus 1 over, but the only difference, you will remove all x's of f of x and you will replace it with the complete function g of x. Again, one more time, whenever you have a composition, look at the first letter, which is f here. So what's the function of f? Write the function of f, 1 plus 1 over x, but instead of this x will be removed and it will be replaced by the complete function of g of x. So we'll write, instead of this x, we'll write the complete function of g of x, which is x plus 1 all over 2. So let's simplify. First, we need to find the fg of x, and then we'll do the composition. So in this case, in math, whenever I have a denominator of a denominator, so this 2 will be up there, so it will be 2 over x plus 1. So we need to simplify this one as much as we can. So it's fg of x here. So I will try to make both of them as one denominator. It will be fg of x equals, here I will multiply the 1 here by x plus 1 up and down, so it will be 1 multiplied by. So how do you find the composition as a proper fraction? I will multiply here by, just let's copy what we reach it there. It's 2 over x plus 1. So I'm going to multiply here by this one. I will multiply by x plus 1 up there, x plus 1 here, and x plus 1 down. And then what we will do is, it will be, the composition is going to be x plus 1 all over x plus 1 added to 2 over x plus 1, and in this case, this is the composition, but we can simplify more. I'm just finding h first, so it will be x plus 3 all over x plus 1. This is the composition, which is the function h. Now I need to find the inverse of h. As we know how to find the inverse, first of all, I'm going to call the function notation with the letter y. So instead of this function notation, I'm going to call it y equals x plus 3 all over x plus 1. So what you will do is you will replace each letter y by the letter x and each letter x by the letter y. It's going to be y plus 3 over x, y plus 1. Then you will try to make y subject again. So here y plus 1. If I want to make y subject again, I'm going to do cross multiplication. So it will be x y plus x equals y plus 3. And then you will keep y's in one side. So you're going to swap the y and the x. It's going to be here xy minus y equals 3 minus x. Then make y as a take a common factor, y as a common factor. It's going to be x minus 1. So it's going to be x minus 1 and here 3 minus x. So the y will be 3 minus x all over x minus 1, and this is y inverse. So at the end, as what's required from you to find h inverse in this as x tends to 3 minus x all over x minus 1. This is the final answer. So what did we do again? We found the composition of f, g, f and g, the function f and function g, and then we simplified the composition as much as we could, and then we got the inverse for h. Let's see one more question for practice. Function with domain x is greater than or equal to negative 3, such that g of x is x squared plus 6x. Write down the range of g inverse, and then we need to express the inverse, g inverse, in the form like this. If you want to find the range of g inverse, here is a relationship that you must understand. Function g, it has domain and it has a range at the same time. The domain are the possible values of x on the x-axis when I'm sketching, or the possible values of x for this function. Like here, the domain is x is greater than or equal to negative 3. So negative 3 and all the numbers that are greater, they are possible to be used here in G. And the domain is the possible values of, the range is the possible values or the possible y values that can be used in the function notation in here. But the inverse here is a relationship that you must understand. The inverse for G here, the domain for G is the range of G inverse, and the range here is the domain. So it's like inverse operation. So what we will do is, here the main domain of G will be the range, and here the range of G will be the domain. So it's like inverse relationship. Like here, this will be this one and this will be this one, but the only difference here, you write x is greater than or equal to negative 3, and here write f of x with something for the range, for example, is greater than or equal something, and here this, what will change? Only the range will go here as x value, and here the range will be f of x of something. So let's see how do we solve. It's like inverse operation in this part. What do we do exactly? Again, the domain of x, or the domain of G, will be the range of the inverse. So the domain of the G will be the range of the inverse, and the range of G will be the domain of the inverse. If G has domain and range, so the domain for G will be the same as the range of G inverse, and the range value, or the range values for G, they are the domain for G inverse. So what you will do only for this to get the 1 mark here, if this is the domain for G, so the range for G inverse will be G of x is greater than or equal to negative 3. So just you will change, instead of x here, you will make it g of x, or you can write y is greater than or equal to -3, or here you can write y is greater than or equal to -3 to take the mark. So the range for the inverse is the same as the domain of the original, and the range of the original is the same as the domain of the inverse. Here we need to express the inverse of g inverse in the form g inverse x intends to, and then here write the function. If we want to find the inverse, here the function is g of x equals x squared plus 6x. So what you will do is you're going to call this y equals x squared plus 6x, and then you will change each letter y by the letter x and vice versa. So it will be y squared plus 6y in here. And then what should you do in this case? To make y subject, you will change x to the other side, and you're going to consider this as a complete equation in y. So it will be y squared plus 6y minus x is equal to 0. Whenever you have a quadratic equation in this form and you need to find the inverse of the function, you have two ways. You can do it by completing the square, or you can use the quadratic formula to solve. So we can use here completing the square. The formula for completing the square, here a is 1 for this equation, and b is 6, and c is negative x. So if you'll do completing the square, the formula is y plus b over 2 all squared minus b over 2 all squared. And if you have c, you're going to add it here. But the main formula is y or x according to the variable you are working with. So it's y plus b over 2 all squared minus b over 2 all squared. If there is c, you must put it. So let's apply this form in here. We have known what's a, what's b, and what's c. We just need to apply in this formula the quadratic or the completing square formula, and then I will try to make y the subject in this case. So it will be y plus b is 6. So if you do 6 divided by 2, it will be 3, and then all squared, and here minus 3 squared, and then minus x, which is this letter c, is equal to 0. So it will be y plus 3 all squared, and here minus 9. You have minus 9, and then minus x is equal to 0. If you shift the x and 9 to the other side, it will be y plus 3 all squared equals x here plus 9 to the other side. Just take square root for both sides. Y will be y plus 3 is equal to a positive or negative square root of x plus 9, and then it will be here the y is negative 3 plus or minus square root of x plus 9, and then here you can find the inverse. But there is something, it was mentioned at the beginning that x must be greater than or equal to negative 3. So if we put negative 3 here, so negative 3 plus 9 is root 6. So negative 3 minus root 6 will give you something less. Here you have negative 3 plus root x plus 9. If you put the x as here negative 3 plus 9 is root 6. So negative 3 plus square root of 6 will give you something greater than negative 3. But if you put put here negative 3 plus 9 is 6. So negative 3 minus root 6 will not be acceptable. So the only solution is x negative 3 plus root x plus 9, root x plus 9 here. So you need to write in this form, it will be g inverse where x intends to negative 3 plus root x plus 9. Okay, and this here, x plus 9. So this is the final answer for G inverse. We can leave it like this. So again, how do you find the inverse of a quadratic function? You will try to make it as a complete equation in x, or in y, sorry, so it will be y squared plus 6y, and then shift the x. So this is a, and this is b, and this is c. So you can do completing a square, or you use the quadratic formula to find the answer, and then here is the inverse, and you need to write it in this form. Then you're done with this question. Let's see one more question. In this question, we need to see that the function f is defined as f of x equals square root of x squared plus k squared all over x for x is greater than 0, where k is a positive number. Find the value of p for which f inverse of p equals k. We need to find p. You need just to pay attention to this sentence or what's required in this question. So what we'll do is, in this case, to make P the subject here, you have F inverse of P is equals to K. So if I want to make P the subject, I need to shift the F inverse to the other side. So to make P the subject, the F inverse goes to the other side as F. So it's like inverse relationship. If f of x here is equal to y, I want to make y the x the subject, so it will be f inverse of y. And for example, if I have here like f inverse of x is equal to y, if I want to make x the subject, so f will go there as f of y. So if I need now to find p as what's required from the question, here I have f inverse of p is equal to k. So the inverse goes to the other side as the normal function notation. So p now equals f of k. So what I will do is I will just go to the function notation at the top of the question. F of x equals root of x squared plus k squared all over x. So you need to replace each x by k. So what I will do is it will be f of k equals square root of, replace each x by k, so it will be k squared plus k squared all over k, and this is p, so we need just to simplify, so it will be 2k squared below the root all over k, so square root of k squared, so it will be root 2k all over k, just cross out k's together, so the answer is root 2. So again, how did we do this part? I need to find p, and it's given here as a hint, f inverse of p is equal to k. If I want to make p the subject, so the inverse goes there to the other side as the normal function notation, so p equals f of k. So f of k is here. You need to replace each x by k in the function notation, so it will be k squared plus k squared all over k, because each x has been replaced by k. Then you add these together, it will be 2k squared all over k below the root. Square root of 2 is, it will be root 2. Square root of k squared is k, and there is k as well. Cancel or cross out the k's together, so the final answer is root 2. Let's see part 2. The function g is defined as g of x equals x squared, where x is greater than 0, given that g of a, gf of a, which is the composition of a, is equal to k. Find an expression for a in terms of k. So we need to find a in terms of k. So what we will do is, now we know the function of f, and here's the function of g as well. To find g of f, for example, of a first, then we replace it with the a, or just you can find f of a directly first. We can find f of a, and then we find g f of a. So let's find f of a. As I told you before, when we are doing substitution, we do the function which is inside first. So you do the f of a. F of a, it means you replace each x by a. So it will be root a squared added to k squared all over k all over a, sorry. And then we need to find g of this answer. Okay, so gf of a, you will take the answer you got, which is here, root a squared added to k squared, and then all over a. So g was x squared, so you will just do squaring for this bracket. To do the square, you need to take care about something that's very important. You will square the numerator and the denominator as well. So it will be like this, the square of here a squared plus k squared, and then the denominator squared. So the square cancels the power, so it's going to be a squared plus k squared all over a squared, and this it supposes equal to k, so you're going to equate a squared plus k squared all over a squared is equal to k. You'll just do cross multiplication, so it's now a squared k equals a squared plus k squared. Make a's all in one side, so we'll shift this there, so it will be a squared k minus a squared equals k squared. So you will take a squared as a common, so it will be k minus 1 equals k squared, and then a squared equals k squared over k minus 1, and then a, you'll do square root, so a will be the square root of k squared over k minus 1, or which can be written as k over the square root of k minus 1, because the square root of k squared is k, and then square root of k minus 1. This is the answer. I'm just going to repeat it once again. What did we do? It's given that g is x squared, the function g, and f of x is defined as here. And then we need to find g composition f of a. So to do this one, I will find first f of a. So I will go replace each x by a in this. So it will be a squared plus k squared below a root all over a. And then I need to do the composition g of f. After the result I got in f of a, I will put it here instead of the x. So instead of the x, I'm going to put all of these. So it will be root a squared plus k squared over a all squared. So the power will be the square of the top and the square of the bottom, or the numerator and denominator. So square root or square and square root, they will cross each other. So it will be a squared plus k squared, and the square of a is a squared. So we have all of these divided by each other. And then this, it's supposed to be equal to k. This simplification is equal to k. I need to find a in terms of k. I need to find an equation or expression a equals something related to k. So I will do cross multiplication. It will be a squared k is equal to a squared plus k squared, and then I'm going to shift the a there, so it will be a squared k minus a squared equals k squared. Take a squared as a common, it will be k minus 1 is equal to k squared. Then this will go there by division, so a squared is k squared over k minus 1. So I will do square root to get a, square root for the top and the bottom, square root of k squared is k, and square root for k minus 1 to remain. F is the function such that f of x equals 4 minus 3x. We need to find f of 5. So I will do just replacement. So you will just replace this by 5 in here. So you need to calculate. It will be 4 minus 15, which is negative 11. And here it says g is the function such that g of x is 1 over 1 minus 2x. Find the value of x that cannot be included in any domain of g. Whenever you have a fractional function and you need to find the excluded points or the not included in the domain always of the fractional function or the reciprocal function is we need to exclude the values that make the denominator is equal to 0. We need to exclude the values that make the denominator is equal to 0. So I will try first to solve the denominator as an equation in x. I get the value of x and then I exclude it. Again, what do? The domain of the fractional function is excluding the value in the denominator that makes the denominator is equal to 0. So I will solve the denominator as an equation in x. Whenever I got the value of x, I will exclude it from the domain. So let's solve. It will be 1 equals to 2x. So x is half. So this value must be excluded from the domain. So x must not be equal to half. So why x must not be equal to half? Just go substitute there. It will be 2 by half is 1. 1 minus 1 is 0. So it's not a function anymore. So this is the value that must be excluded from the domain. This part again, whenever you have a fractional function, you will look at the denominator. The value of the denominator must be the value in the denominator that makes it equal to 0 must be excluded from the domain. So you will take 1 minus 2x is equal to 0, and then you shift the 2x to the other side like you're solving an equation in x. So x is equal to half, and then you must exclude this part. If you want to make sure that your answer is correct, just go substitute the value that you got here. If it makes the denominator is equal to 0, so this value must be excluded. Here, if we need to work out the composition of negative 1.5. So first of all, we need to find the g of negative 1.5. We'll do just substitution. And then what I got after substituting in g, I'll go replace it in f. So let's find g of negative 1 first, negative 1.5. So you replace it in here. It will be 1 over 1 minus 2 multiplied by negative 1.5. So when you substitute, it will be 1 over. Here, the negative 2 by negative 1.5, it will be positive 3. So it will be 1 plus 3, which is quarter. So it's 1 over 4. The g of negative 1.5, I will just take the 1 over 4 and replace it in f of x. So it will be f g of negative 1.5. It will be 4 minus 3 multiplied by 0.25. It will be 4 minus 0.75, which is 3.25, or you can just write it as the mixed number, 3 and 1 quarter, or can be written as 13 out of 4. Let's see one more question. Here, this one is very important, and every one of you must pay attention to such questions like this. The function f is such that f of x equals x squared minus 8x plus 5, where x is less than or equal to 4. We need to find the inverse. Whenever you have a quadratic function, quadratic means you have x squared and the rest of the expression that's written in the form ax squared plus bx plus c. This is called quadratic. Maybe it can be x squared plus bx only. These are both of them called quadratic equations. If you want to find the inverse of quadratic equations, what you will do the normal steps, which is replacing the function notation by the letter y. So it will be y equals x squared minus 8x plus 5. And then you will change each letter x into y and each letter y into x. So it will be x equals y squared minus 8y plus 5. And then you will make it as an equation into y by considering the x as a constant and shift it to the other side. So it will be y squared minus 8y plus 5 minus x is equal to 0. So a of this equation is 1, b is negative 8, and c is 5 minus x. So now we considered a is a constant in this equation. We considered the x as a constant of the equation in y. So what you'll do, you have two ways to solve it. You can do it by completing the square, or you can do it by the quadratic formula. So I will work on the completing a square formula. Completing a square is y plus b over 2 all squared minus b over 2 all squared, and then if there is c, you will add it, is equal to 0. So what we will do in this case, the formula is here, but why did I equate it to 0? Because Now we made it as an one equation. So what I will try to do, I'm going to apply the formula of the completing square in this equation, and then I will try to make y as a subject to find the inverse of the function. So let's apply it here. It will be y here plus negative 8 over 2 all squared minus negative 8 over 2 all squared, and then plus 5 minus x is equal to 0. So it will be y minus 4 all squared minus 16, and then plus 5 minus x is equal to 0. So it will be y minus 4 is all squared. Here we have minus 16 plus 5 is minus 11 minus x is equal to 0. So it will be y minus 4 is all squared equals, to the other side, x plus 11, because I shifted these two together, the other side. And then I can take square root for this part to remove the power 2. Okay, so we just stop here on this part, which is y minus 4 whole squared equals to x plus 11. So it will be y minus 4. I'm going to take square root for the two sides. So it will be square root for 11 plus x, or x plus 11, and here plus and minus. So it will be y equals 4 plus or minus the square root of x plus 11. But you must take something that's very important. Here we're going to change this into x plus 11. Here it was mentioned that x is less than or equal to 4. So in this case, we'll just take the minus sign. But if it was greater than or equal, we were going to take the plus sign. So according to the domain which was mentioned at the beginning, so the final answer, or the proper answer, must be y inverse equals 4 minus the square root of x plus 11. So the f inverse here will be written as 4 minus the square root of x plus 11, and this is the final. In this question, we can do this part. The question says, find fg of 3. So you will replace 3 in each x of g, and then the result you put it in f. So g of 3 first is, it will be 3 minus 10, which is negative 7. Then go put this there in the f, or the function f, you can get the answer. You put this there as negative 7. Okay, yeah. So it will be negative 7 squared added to 6. So it will be 49 plus 6, which is 55. So the answer is 55. So what do? We just replace 3 in this function. 3 minus 10 is negative 7. And then I took the negative 7, put it here. Negative 7 squared is 49. 49 plus 6 is 55. Now it says solve the equation f composition g is equal to f of x. So I need to find the composition for these two functions, and then I equate it to the function rule of f of x, and then I solve an equation. So let's do it together. So if I need to find the composition, it starts with the letter f, which is x squared plus 6, but you need to remove the x and replace it with the complete function of g. So to put the function of g, it will be x minus 10. This is the composition, f composition g of x. Let's simplify it, and then I will equate this one to the f of x itself. This will be x squared if you expand the bracket, and here plus 100, and then you have minus 20x added to 6. This is the composition. So the composition will be, at the end, as a simplest form, is x squared minus 20x plus 106. And this one, make it equal to the function notation of f, which is x squared plus 6. So if you want to solve this, what you will do is you can cross out x squared and x squared. So it becomes now negative 20x plus 106 is equal to 6. shift this there, so it's negative 20x equals 6 minus 106, so it's negative 100. And then we have here negative 20x. So divide by negative 20, divide by negative 20. So x would be 5. So we got x as 5. And we have shown clearly, after we got the composition first for the two functions by writing the first letter, which is the function f, which is x squared plus 6, but I removed each x and I replaced it with the function g, so it's g minus 10 all squared plus 6 gives me the composition. Then I expanded this bracket, I added a 6, I simplified as much as I could till here, so it becomes x squared minus 20x plus 106, and then I equated this part, the left hand side with the right hand side, which is f of x, the function notation of f, then I solved the equation. So we can just remove this part and right above this one, it's the composition here. This is the composition, and here f of x, we can just write the f of x to stop the confusion. If someone's watching the video will understand what's going on. Here in this part, the rest of the question says the function h is defined as h of x equals 2x minus 4 over all over x. State the value of x that cannot be included. As I said to you, the parts that must be excluded from the domain whenever we have a fractional function or reciprocal function, it's the denominator. I don't want the value in the denominator that makes the denominator equal to 0. So what's the only value that make the denominator is equal to 0 when x is 0? So I don't want x equal to 0. So the only excluded value is 0. So whenever you have a fractional function, you must look at the denominator. Check the denominator very well. What's the value that makes the denominator equal to 0? Since x is only here, a variable without any other operation. So you're going to consider x is equal to 0, but it's not accepted x is equal to 0. So the excluded value will be 0. If you want to find the inverse for h, what you will do, all the steps like what we have done in the previous examples, it will be y equals 2x minus 4 all over x. So just to change the letter y by the letter x and the letter x by the letter y, and then try to make y subject again. So we'll do cross multiplication, and then we'll keep y's together on one side. So it will be xy minus 2y equals minus 4. Then take the y as a common, so it will be x minus 2 equals to negative 4. Then y will be, or y inverse now will be negative 4 all over x minus 2. So h inverse is negative 4 all over x minus 2. This is the inverse of h. Let's see one more question. The last question for today, let's see how do we do this one. The question says the function f and g are defined as f of x equals x squared minus 10x plus 7, x is greater than or equal to 1. G of x is equals 7x minus 6. We need to find, first of all, the composition at 2. So look at the second letter, which is g. You'll go replace each x by 2. So g of 2 is 7 by 2 minus 6. It will be 14 minus 6, which is 8. And then take the 8, replace it in x. So it will be f of 8 equals 5 by 8 squared minus 10 by 8 and then by 7 plus 7. So you're gonna have 64 multiplied by 5. That gives me 260. 260 minus 80, which is 8 by 10. It's 180 plus 7, so it will be 187. This is the final answer for the question. So what do you do again? You just replace the value of g in here. 7 by 2 is 14 minus 6, which is 8. And then take the result right here. It will be 5 by 8 squared minus 10 by 8 plus 7. So this is the answer. We need to express the inverse function f inverse in the form f inverse of x. So f is a quadratic function, as I mentioned in previous examples in the same video here. So what do we do in this case? Since it's a quadratic, so this is only minus, not plus. So we will need to make the inverse, or finding the inverse, so it will be y equals 5x squared minus 10x plus 7. So what I will do is I will change each letter y by letter x, so this will be x, and here it will be 5y squared minus 10y added to 7. Just make it one complete equation in y, so it will be 5y squared minus 10y plus 7 minus x is equal to 0. So a here is 5, b is negative 10, and c is 7 minus x. So you need to take care about something that's very important, that if you want to do completing the square, you have a value written before x or the y squared. You will just use the completing square formula. Completing square formula is y plus b over 2 all squared minus b over 2 all squared, then added to c. So we can just directly start applying the completing square formula, but before applying the completing square formula, I must take 5 as a common factor, because completing square formula cannot be applied when you have a coefficient that's greater than 1. So it will be 5 out, and then minus 2y plus 7 minus x all over 5. So what did I do again? I took the 5 as a common factor, so I will keep it out for now. I will do completing the square for everything inside. So I'm going to consider this one as a no function in y. I will do completing square for what's inside the bracket. So it will be y. b now is negative 2. So it will be negative 2 divided by 2 is negative 1 all squared. And then minus 1 squared added to c, which is 7 minus x all over 5 is equal to 0. So the 5 remains out. So it will be here y minus 1 all squared, and then minus 1 plus 7 minus x all over 5 is equal to 0. So we can expand the 5 again. So it will be 5 by y squared minus 1 all squared, then minus 5 plus 7 minus x is equal to 0. So what did I do again? I expanded the 5 by put it here before the bracket, and then multiplied by the negative 1, and then multiplied by this fraction. So now it will be 5 by y minus 1 all squared. Shift all of these, or just you can simplify. Minus 5 plus 7 is a plus 2. If it goes to the other side, it will be x minus 2. And then you divide by 5, so it will be y minus 1 all squared equals x minus 2 all over 5. And then you take the square root. Let's continue here. So it will be y minus 1 equals the square root of x minus 2 all over 5. And then y will be 1 plus or minus square root of x minus 2 all over 5. But you will exclude the minus because it was greater than or equal to 1 here from the beginning. So this is the y inverse, or the inverse of the function. It will be x minus 2 all over 5 below the root. So it will be x minus 2 all over 5 below the square root. This is the inverse of the function y, or the function f. So the final form of the inverse can be written here as 1 plus the square root of x minus 2 all over 5. This is the answer. We are done for today's video.